Hello, everyone. Again, my name is Dianne Gonzalez, and this is actually my job. I'm the Principal Technical Marketing Engineer for our Cloud Data Services business unit at HPE. And today, I'm going to give you an introduction to HPE Cloud Volumes. I'm going to talk to you about the products that are currently in our portfolio and our platform, as well as show you quite a few demos so that you can put the pieces together of the value add we bring to the table, especially when it comes to cloud integration. So for those of you who are watching the last presentation, I finished with the slide that had this concept, and this time around I'm going to start with it because it's the background or the premise of our story, right? When we talk about the vision and definitely the trends of what we're seeing with our customers and generally in the technical field, this idea of cloud mobility, everything as a service, simple consumption models, the ability to scale elastically and on demand, and also the ability to build and deploy my workloads, applications anywhere has become the leading concern, right? All of these components put together describe what we like to call an agile environment or more of a DevOps environment, right? Where we can minimize the time to market for any of our applications by abstracting all of the hard components or the sticking points that would help us get there within an enterprise. And we want this to span when we talk about cloud, right? Very few organizations right now are just in the data center. As a matter of fact, data center itself has been re-architected to more implement a cloud type of feel, right? Which is why most on-premises data centers now are being called private clouds, right? Owned by a single tenant, typically the owner being the enterprise. We want to also be able to span the edge and the public cloud. And workloads is sort of the low-hanging fruit. That's easy stuff if we think about it from what points have gravity, right? Security is one that has gravity and is a little harder to talk about. And definitely data is probably the one that raises the most questions when we talk to customers. And when we talk to our customers, and we've done our conversations with different analysts, what we found is that most of the enterprises that are out there right now are caught in this, let's call it a bimodal world, right? So we've got the traditional way of deploying applications. Most of them have since migrated their applications at least to a virtualized infrastructure. But there are still plenty of what I like to call, or what I did when I was an infrastructure administrator back in my heyday, we called them pizza boxes, right? Also box of hacks. But anyway, somebody got that one. But most of them have at least moved into some sort of hypervisor type of technology or abstracted the infrastructure underneath. But still, the want, building on the previous slide, is to kind of go into this DevOps mode, right? How do I continuously integrate, deploy, build my applications? How do I continuously test them? How quickly can I get to market? How agile can I make that? And what we're seeing is not only the leveraging of hypervisors to do that, but to bridge this gap, we're also seeing containerization take a heavy, kind of a heavy foot in this discussion. Containerization, by the way, is typically built on top of these hypervisors to add a little bit more to this paradigm, right? And what we want to do when we're talking to our customers in this bimodal world is, number one, we want to offer them a solution that has great availability. Now, in the case of where we are now with HPE Cloud Volumes, I'm going to be talking a lot about HPE Nimble Storage. And that's why I've got this 6 nines of availability here, which is one of the things that off the bat we can offer them with these solutions. The other thing we can offer them is a unified, consistent application, data services, and data mobility and portability. Going back to my original point, data has gravity. Out of all of the things that are difficult for a customer to do right now, it is what do I do when I have 50 petabytes of data, or we can even go smaller than that. What do I do if I have 2 terabytes of data for a singular application in the data center, and I want to make those 2 terabytes agile? What do I do? What if I want to take them to the cloud? How do I do that, right? Consistent application data services, I've talked several times about this idea of abstracting different layers of the infrastructure. At each point in those abstractions, the other thing that we want is APIs, right? Because that's going to allow us, again, thinking of in a more DevOps kind of fashion, to automate a lot of my build cycles, my life cycles, right? So we're talking about these paradigms. And we're talking about, in particular, and this again this is a consensus based on research that we've done not just with our customers, but with analysts as well. These are the typical workflows that we want to build targeted solutions for, and that we, in particular, in the cloud data services and cloud volumes, this is the thing that we've focused the most on. So bidirectional migration, the ability to simply and efficiently move workloads, answering that data has gravity question as well as the workload itself. Hybrid CI/CD. Build in one location, deploy in another. Notice I said build in one location, deploy in another, and I didn't automatically tie it to the local data center because we have plenty of customers right now. How many of you have heard the term cloud first? We've got plenty of them right now that are going in that direction, which means they want to get rid of their on-premises footprint altogether, which means they may want to build their, let's call it their production workspace in cloud number one because of the APIs, availability, et cetera, that's available. But then maybe the best of breed service for DevOps, maybe price point, is in cloud number two. How do they bridge that? How do they deploy data across both of them? How do they secure it? Hybrid AI and analytics, same type of concept. But here the idea is that we want to be able to scale elastically in a cloud. Multi-cloud production, again, run applications across multiple clouds, including on-premises. Many of you have seen or heard of hybrid applications where maybe the data or a component of the application that requires maximum governance to meet certain SLA requirements is running on premises, but maybe the access points, the client access points, are scaled elastically in the cloud. And then, of course, there's hybrid data protection. Run in one cloud, recover to another. SimpliVity. When we were talking about their new RMC integration, one of the first questions that came up in that discussion is, can I take that to the cloud? Right? When we were talking about Primera, when we archive to the cloud, how do we get that data out? What do we do with it? Help us out, right? So these are the things that we've targeted in the Cloud Data Services business unit with HPE Cloud Volumes. Again, building upon the challenges that are right now in the enterprise, that bimodal world, and then finding a way to target solutions toward these problems. So what's on the truck right now? When we talk about Cloud Data Services and what's available, we have HPE InfoSight. We tie into HPE InfoSight just like the rest of the platforms. Our product would not be helpful if it was an outlier when we have wrapped every other piece of the portfolio behind InfoSight for AI-driven analytics, right? HPE Cloud Volumes Block, that's our flagship service. Many of you have already heard of this in the form of HPE Cloud Volumes. We've had this now for, this will be going on the third year, available as a service. All right. HPE Cloud Volumes Block provides enterprise-grade multi-cloud services for storing and managing data in public clouds. Let's make that into layman's terms, right? What we provide is block storage in the cloud with enterprise data protection and data management, flexibility in provisioning, whether through capacity or performance, the ability to migrate data between all of the clouds, including back on premises without egress, built-in replication. Anything that's got HPE Nimble storage in it right now is ready to go to HPE Cloud Volumes Block through built-in replication. No external data mover required. All of these, as well as the platform benefits that are already included to HPE Nimble Storage, are available to HPE Cloud Volumes Block, meaning encryption. If you want to encrypt your data, you can. If you want to use performance profiles, meaning you want your volumes to have a certain block tied to them. Maybe you know your application communicates at 8K, so for optimum throughput, you want to use one of the performance profiles. You can do the same things at HPE Cloud Volumes Block. So we take some of those things, snapshots, clones, et cetera, and we take them to the cloud. That is the core of HPE Cloud Volumes block. So quite a few things, and that's what we'll be talking about most in this presentation. And then the last one is HPE Cloud Bank Storage. All of these comprise, HPE InfoSight isn't part of Cloud Data Services, but we leverage it heavily. But these two, HPE Cloud Volumes block, which includes replication, and HPE Cloud Bank Storage combined, we've got over 350 petabytes of storage managed right now. All right, and it's growing. And good things are coming in the next few months. That's all I will say. So let's take a look at HPE Cloud Volumes block in a little more detail. I've already talked to you about some of the enterprise features we bring to it. So we're able to scale dynamically performance and capacity. How many of you are familiar with the block storage offerings of the cloud right now? Just a show of hands. Okay, so since it's not everybody, I'll just say one thing. The block storage offerings in the clouds are great, and the hyperscalers are great, but they are meant to take advantage of something called economies of scale, right? Which means I'm going to give you a service or something that's going to be good enough for you to do your work. And that good enough is very important to the customer. You know why? Because what does it do to the price point? Right? It allows them to get it at a better price point. Now, we could go into a real big rabbit hole if we start talking about whether or not moving to the cloud is cheaper than staying on premises. Because I think that that has been a very big eye-opener for customers. I think in the long term and with the proper prior planning, right, it can be a lower total cost of ownership. But for some customers, what they're finding is when they move to the cloud, it is expensive. I'm not telling you a story here when I tell you that one of our customers, a 3-part customer, decided they wanted to move a portion of their data into a cloud-first initiative and ended up spending $500,000 a month with AWS. Ouch. It wasn't a good day for that TCO. They got fired. So, sorry, CTO. So scale performance and capacity independently. Again, going back to the economies of scale, because it's a lower price point when we're talking about block storage in the cloud, there's not a lot of bells and whistles to it, but it's good enough. But one of the things that you can't do is, for example, let's say you have a workload that requires 50,000 IOPS. You can't, and let's say that the data set itself happens to be 500 gigs. You can't just create 500 gigs with 50,000 IOPS. What you have to do is you have to add more disks, because it's a scale-out storage system, right, underneath the hood. So you actually have to add more capacity in order to meet that performance.
So just to be clear, this scenario you're describing, is this with HPE Cloud Volumes block?
This is traditional block in the cloud.
Because I was going to say, wow, that's a pretty terrible product.
Wow, now you said that, not me. So now, Stephen here mentioned that it could be really bad if a customer were tied to such limitations. The beautiful thing is HPE Cloud Volumes block is not tied to such limitations. If you want to create a 10 gig data set at 50,000 IOPS, guess what? You can. Just like that. Let's say that on a Sunday, you need 20,000 IOPS, and on a Monday, you need 5,000. And you only need those 20,000 IOPS on a Sunday. Monday through Saturday, you need 5,000. Guess what you could do with HPE Cloud Volumes block? You can run a job, set on Sunday, 20,000 IOPS. The end of Sunday, 5,000 IOPS. That's it. Everything we do is driven through APIs. You can leverage the portal, or you can use APIs. Big deal in cloud right now is automation. So our service has APIs that allow you to drive that automation with anything you can do in Cloud Volumes block. Clones, snapshots, restores, promotions, changing of IOPS, changing of capacity. All of that can be managed through API calls. Low latency data access. I get this question all the time. Because of the way HPE Cloud Volumes is structured, how can it be performant? I get this question all the time, and I say, okay, I'll tell you why it can be performant. Number one, because we house HPE Cloud Volumes next to all of the data centers for the hyperscalers. We use Equinix. Equinix has got, not to get too much into this infrastructure rabbit hole, let's just say they have big pipes to these data centers. Lots of throughput. Beautiful part is when you write to HPE Cloud Volumes block, the moment you write, it's acknowledged. When you write to any of the hyperscalers, how many times does it have to be written? At least to give you redundancy. At least twice, more, depending on the type of storage that you write or that you choose, which means that you're going to incur latency. So we're actually very performant. To give you an example, in US East, depending on the workload, we can average 5 milliseconds or less, and in some workloads, we can do sub-millisecond performance, all right? So yes, we're low latency data access. Again, multi-cloud, we can present to AWS, Azure, or Google without data migration. What does that mean? Because of the way Cloud Volumes is structured, for us, presenting data to AWS is as simple as presenting data to Azure and Google. Why? Because we leverage the Equinix networking, which means all we have to do is provision a circuit to any one of those clouds directly and securely into the customer VPC or VNet. Customers get a dedicated interface, or in the case of Google, we leverage the interconnect. Again, we have the data management on the back end, snapshots and clones, the same type of things that customers are leveraging, not just the ability to back up data, but when we talk about the enterprise, hopefully you've got a good storage platform on premises and you're not restoring all day, right? What are you more than likely doing with what the platform is able to do? Lots of cloning for reporting, DevOps, testing, single item recovery maybe. Lots of use cases for clones. Those snapshots and clones, that flexibility, that dynamic workload capability we take to the cloud as well. Right now, if you're working within the native hyperscaler, they do also do snapshots, but those are tiered off into a different tier of storage. Microsoft Azure allows you to choose the type of storage you want to tier those snapshots to. But in essence, when you're creating a clone, what you're doing is you're building a new disk from a snapshot. So if you have a 5 terabyte data set and you need to clone that 5 terabyte data set, what you're doing is you're duplicating it. So you now have a new 5 terabyte data set and you're paying for all of that capacity. In the case of Cloud Volumes, the clone is instant. You don't pay for it, because just like with nimble storage on premises, what we're presenting to you, the volume, is based on redirection of metadata on the back end, right? So clone presentation is instant, the data set is instant, and you're not paying for another 5 terabytes. You're only paying for writes as you incur them and the IOPS that you provision to that volume that you've cloned. All right? So in the case where you have a clone strictly for reporting and you're not writing anything, you're not paying for capacity, you're only paying for the IOPS you've provisioned. IOPS are not tied to the parent volume. So if you have in production a 50,000 IOP volume and you only require 5,000 for reporting, you can set the clone to 5,000. At all points, we have an ability to change or modify based on the workload requirement.
Do you support thin provisioning?
Absolutely. So our snapshots are thin provisioned. Our clones, in essence, what I just described is thin provisioned. That's why we do not charge for the data set. All right? No lock-in. No egress charges, complete visibility. So when we talk about no lock-in, what we're talking about here is, again, you have the ability to take your data set to any of the clouds, whether by cloning or whether by I'm moving this completely from AWS to Azure.
You actually have to move that data?
Good question. You do not. Again, because of the nature of our service, what is it that we do to present the data from one to the other? We build a circuit. We do that automatically to the customer, and it happens instantly.
And so it's native block storage. It's not actually object-based or S3 compatible.
We do, right now, block storage.
Right.
Okay? That's Cloud Volumes block. The name is not lying to you.
I understand this.
So when it comes to egress, what we're hitting here is that point that you just talked about, Mr. Lieb, which is essentially you don't have to migrate the data, you just repoint it. Now, if you're taking a volume that you've replicated to the cloud and you want to move it back on premises, replicate it back to an on-premises nimble storage array, you don't get charged for egress there either. We own that circuit, so we do not charge you for getting the data out. All right? Now, if you want to go from AWS, for example, US East, they all have different prices, but again, let's go to AWS US East. If you want to migrate data from block storage to, let's say, Azure, you're getting charged 9 cents a gig. Look it up, not lying to you. Right.
With egress charges.
Egress.
Mm-hmm. What about attachment to the other hyperscalers, cloud volumes? Let's say you need compute now. let's say you want to do something there. Is there egress charge there, or is that a direct connect? Or?
Nope. So let's say I want to take my data that's living in Azure in a VNet, okay, and I want to move it to AWS, to the VPC. All I do on the back end is I say I'm no longer pointing it here, I'm pointing it over here instead.
Yeah.
Right? The compute, okay, we do not provide compute. That is what the hyperscaler is for. We provide you the data. We're answering that data has gravity question here, right? Now, let's say your data set is now in AWS, but Google has excellent analytics. So now I want to take a portion or all of my data set, and I want to put it in Google somehow. I want to de-identify it, and then I may want to put it in a warehouse of some sort and do some sort of analytics on it. Guess what? At that point, what we're doing is we're creating a clone, and we're taking that clone volume, and we're pointing it to Google. Again, instant. You're going to see that in these demos. So let's take a look at the whiteboard, or blackboard, since we changed our templates, and now it's black. All right, so right now what I'm going to show you, I'm going to start off by showing you a cloud-native use case, right, which is essentially I've provisioned a volume in HPE Cloud Volumes. At that point in time, I can attach it to compute in the hyperscaler of my choice, whether it be Google, Azure, or AWS. To Miss Elliott's question, thin provision snapshots at the schedule that you choose. We can use those to provision clones, and we can attach those clones to a different compute instance in the same hyperscaler, or to a different hyperscaler in a different compute instance. Because of the way we've structured Cloud Volumes, we can now take enterprise type of applications to the cloud in a native format. What do I mean by that? I get this question all the time. I move to the cloud. Does that mean that my application is fault tolerant? Yes or no? Anyone?
No.
Oh, thank you, Lord. Yes, it's not. It's the first time I've asked this question and people said no. Correct.
Cloud 101.
That is absolutely correct. People assume that because I've moved my data or my application to the cloud, it's immediately fault tolerant. It's not. And this is where things get a little challenging with the cloud, and you have to read between the lines and learn how to architect in the cloud. The cloud is great, but you have to know what you're doing. So typically, when you move an application or you create an instance, just a vanilla instance in the cloud, you're working within a zone. Some hyperscalers got into the zone game very late. So some hyperscalers in some regions don't even have zones. So what's a zone? It's equivalent to a data center.
Rack.
So now you create your compute. That's a good point. Because in some, unless you turn on HA, you're working in one rack to boot, right?
Yep.
So now you've created a compute instance. It's in a data center, just like it would be on-prem. That data center goes down, your compute instance goes down with it. How many times has that happened?
Many.
Historically?
Historically.
A lot.
Quite a few, right? Some of them blips, some of them not so blippy.
Think
Texas, what, a year ago? South Central region, year and a half ago? Azure suffered a,
Lightning strike.
well, it was an electrical anomaly. That,
All of my friends in Texas
Yes.
called it.
that in essence took down their region because at the time they only had one zone in that region for, in some cases, up to 48 hours.
I like the example of the Sydney data center getting flooded and having no other region in all of Australia at the time.
Yep. Right. So these things do happen. Acts of God happen. And people assume because I've moved into the cloud, I'm all of a sudden protected from those. You're actually not. So typically what you would do if you want to build a fault-tolerant application is you would have nodes living in multiple zones. And therein begins the challenge. Because, hey, I'm accustomed to building a cluster on premises with shared storage. How do I do that in the cloud? Is that even possible? Right? And so, yes, yeah. And so then that starts to build the challenge. With Cloud Volumes, you can actually do this failover clustering scenario. Because Cloud Volumes are available to all zones in a region. So I'm able to present the same storage to multiple zones in a particular region. Now, you're going to have to pronounce your first name for me.
Voon.
Voon. Mr. Pham here?
That's
Pham?
fine. That's fine.
brought up an excellent question, which is about regions. Right now, when it comes to cross-region replication and cross-region availability, you can work that very easily into the actual application tier. That's very common. The challenge becomes working locally in the data tier, right? So a lot of the hyperscalers have tried to work around this. What they've got right now is the ability to replicate snapshots between regions, at which point you build a new disk or a new data set, and then you can work from that in a multi-region environment. We hope to address that with, while we can do the same thing in cloud data services, we hope to address it in an even jazzier way in the future. So keep an eye out, that's all I can say about it.
Is jazzier a technical term?
It is.
So just
It's
to be,
Puerto Rican for awesome
just,
in English. So
so just to be clear, the customer doesn't need to worry about regions and zones at this time?
they're always going to have to worry about that because of the application tier. We don't control the application tier. We can only control the data tier. So anytime a customer, and I deal with this question all the time, because of the nature of what we provide with cloud data services, I'm constantly involved in architecture for a customer. And I have to explain this to them. Hey, you moved your application to the cloud. Do you think this web server is not going to go down? Okay. You're using this platform. Did you read the fine line between the platform? This enterprise Kubernetes cluster you just built in EKS is in one zone. So that zone goes down, all three of your servers go down. We need to stretch, even platform offerings, you have to think about where they live and how they're structured.
It's like plugging both power supplies into the same power.
Yeah. And what's funny is that, when we're talking about infrastructure as a service, these things are more obvious. It's not so obvious when we talk about platforms as a service, like for example, AKS, EKS, and GKE, databases as a service. It's not, once you start getting into the platform and software as a service tier, people don't read the fine print and realize that it costs extra to build these things in a fault-redundant fashion.
Go with Lambda.
Right? Again, everything is provisioned either through a portal or through APIs. In our particular case, cloudvolumeshpe.com is the portal from which we work. And let's not forget that we can take any data set that we have on premises right now on HPE Nimble Storage and migrate it to the cloud with native replication. Now, the next question you're going to be asking me is, Dianne, again, this is InfoSight plugged into my brain. Dianne, we have a large portfolio. Does anyone else interop with Cloud Volumes? And the short answer to that is right now, no. But we have good things coming in the future. Please stay tuned. That's all I can say about it, right? And so everything is plugged into InfoSight Predictive Analytics. One of the key complaints, and if you read the analyst white papers out there, Gartner has a really good one, Kentic has another one, 365 Research has a really good one that deals specifically with this topic, administrative overhead costs in the cloud. One of the biggest complaints for customers going to the cloud is that they lose the ability to see where they are incurring costs. It's not technically that they lose it, it's just that it is kind of complicated to get that information out of the cloud. If you're not familiar with how the administrative reporting works, it can be a challenge. We leverage InfoSight Predictive Analytics to present cost data and metrics, not just of performance and capacity, et cetera, that you would expect to see from a storage standpoint from HPE, but also cost is also something that can be reported directly from the portal, right? These two work hand in hand. But we provide that information to the customer. If the customer wants to see how much a particular volume is costing them and how that is affecting the amount of credits they have purchased with HPE Cloud Volumes as a service, they can see that immediately. They can report on it as well.
So is it a dollar amount or is it a credit amount?
So we've changed the way that we do the purchasing of HPE Cloud Volumes, and now what a customer does is essentially they purchase credits.
Yeah.
But they can use those credits to access any service in our portfolio. Right?
Is that direct to the customer, or can it be through a partner?
Both. So we have partners that can quote it, as well as it's available through GreenLake, as well as it could be a direct sell.
And this is literally an extension of your own Nimble architecture. So the InfoSight plugs into your own native
It is built on
InfoSight set.
HPE Nimble storage technology, yes, sir.
Right. Is there any plan to extend that to 3PAR or Primera or any of that stuff?
The plans are to extend functionality to those on-premises platforms. Whether or not we change the makeup of the back-end technology, it's a question of gains.
And that's the question there is how interactive is Nimble to those other arrays?
So right now, Cloud Volumes integration is only native with HPE Nimble Storage on-prem.
Correct.
The goal is to have it be just like it is from the view, from the glasses of the end user managing the storage system on-prem, just like the experience a Nimble customer has. We want to make sure that a three-part customer, a Primera customer, DHCI customer has the same experience. And actually, DHCI has the same experience already because it's Nimble Storage on the back end. So really Primera, SimpliVity, et cetera.
Okay.
Right? That is the goal. We're not there yet, but that's the goal.
No, that's fair. I mean, it's good. The process and time and
Absolutely.
And development does.
Yeah,
take
because
time.
keep in mind, for those of you that don't know, HPE Cloud Volumes launched before we were acquired, right? So as we continue to build the portfolio, we're of course building for the platform as well. For the portfolio as well.
So wait, I didn't know that. It launched before you were. Who launched it? HPE?
Nimble Storage.
Nimble.
Nimble, yeah, okay. So it was not HPE Cloud Volumes at the time?
It was just Nimble Cloud Volumes.
Oh, that was a clever name for it. Yeah, okay.
Hard to believe.
Yeah.
Yeah, I always thought
We
it
went
was
from Nimble Cloud Volumes to HPE Cloud Volumes. It was swooped
just
how that
brilliant.
happened.
I always thought it was a compelling architecture, and I've promoted it to my customers on a number of occasions, particularly when they wanted to place large database data sets within the cloud. They could have the compute in AWS, Azure, wherever that they felt comfortable with, but this would mitigate a lot of the storage costs of a large database or something
Right.
along those lines.
It's meant for the gap. I get this, so I'm just going to kind of build on what you just said there, because I get this question all the time, which is, okay, so AWS has provisioned IOPS SSDs, they have standard HDDs, they have a block storage offering. It's called EBS, right? Why then, if it's already integrated into the hyperscaler, why would I choose Cloud Volumes, right? And I'll answer this honestly because it's an important point to note. If a customer is building something in the cloud that has stagnant data or not dynamic data, that's just going to be out there, going to change very little, they don't want to do any type of, I want to call them enterprise workflows that they are accustomed to doing on premises, on that workload in the cloud, they will be better off choosing EBS, even though, by the way, Cloud Volumes is less expensive than provisioned IOPS SSDs for AWS. However, they would still be better probably served leveraging maybe standard HDDs or some other service, lower tier service of EBS.
Because of
the cloud.
latencies?
No, because where we really start leading the charge is when a customer wants to, for example, do clones. The moment a customer, and it sounds so simple because we're so accustomed to thinking from an on-premises environment, clones is table stakes. Guess what? In the cloud, it's not.
Right.
A clone is a copy. So the moment a customer wants to do something as simple as a clone, which is something that administrators are doing daily,
Right.
right, for their day-to-day workflows, we start coming ahead, and we start coming ahead quickly. The moment they want to take workloads and move them between clouds. All of the analysts, again, there's great white papers out there. Kentic, 465 Research, 365 Research, or is it 465? 451, whichever ones. Gartner has another one. Multi-cloud is not an arbitrary choice. We hear multi-cloud all the time. It's not an arbitrary choice. People don't wake up one day and they decide, this Azure thing, it's long in tooth. I'm moving to Google. It's not the way decisions are made. Here's a more realistic thing. Azure is really great for me to run my SQL databases. I've already extended my Active Directory from my on-premises environment into my Azure environment. They're awesome for my hybrid cloud use case. My DDNS is already set up and ready to go. It's as if I'm working on-prem in the cloud. Holy smokes. My DevOps team over here, they have their own operating budget. They're tired on waiting on me and my budget. And they like the APIs of AWS better. They're going to go to AWS. How much control do you think Central IT has over that? Very little. Sprawl is a major thing, right? That is a more likely scenario. And the problems that arise from that then have to be solved, which is, okay, now my DevOps team has decided to use AWS, maybe for good reason. Because yes, it could be for this particular use case for what they're trying to do from an agility standpoint, it is cheaper. And also, the APIs are deeper. AWS has wonderful APIs for any development platform. That is their claim to fame. They're Disneyland for developers, right? So that's not an arbitrary choice. That's one based on business logic, right?
Theoretically.
Here's the question. The developer needs the schema from this database over there to do their development. How do I get it over there? Wait a minute. Maybe they just don't need something as simple as a schema, which can be relatively easy to move. What if they need a data set? How do I get it over there? And then how do I get it over there not only once, but twice, 3 times? Now they say they need it as soon as I update it over here. Now they say they need a weekly copy. How does that happen? We solve that problem with Cloud Volumes. That's when you start getting into those types of workflows, whether it be cloning, whether it be snapshots. Now snapshots, we talk about backup here briefly in several of the sessions. How many people here think that snapshots are still used as an operational form of disaster recovery?
Well, they are.
Thank you. They are.
Yes.
They are.
Should be.
Okay?
Should be.
It's a different question.
So here's the thing, and we can go down this rabbit hole all day because I used to be an infrastructure administrator. I'll tell you what our backup scenario looked like on premises. Okay, at the time, I was not leveraging HPE storage platform. I was leveraging somebody else. I made extensive use of their snapshots, locally replicated those to another array, and leveraged TSM as well for my tape, and to boot, archived to Iron Mountain. That was my entire
Never been in
backup
an
strategy.
architecture like that before.
Holy smokes. That was our entire lifecycle data, right? Our backups. If the crap hit the fan, and that is technical terms right there, the oh crap button was pressed.
Isn't it when rather than if?
Well, no, if, remember, we would all like to think that we were excellent infrastructure administrators and that we had excellent support from our CTOs.
You didn't know me. I was
And we built the most resilient environment ever, anywhere. I think this is where somebody laughed when I said box of hacks, because I think we characterized everything as box of hacks. Because it was always like, we need $1 million to build this. You have 250,000. Okay, let me go back, right? So you did what you could with what you had. But, all right, so when the crap hit the fan, let's say it hit the fan on a Sunday at 12:59, if I had a snapshot from Sunday at 12 o'clock, how many of you thought, and I knew that that data was intact. Am I going to my snapshot, to my DR, or to my tape, or to Iron Mountain? Which one?
Snapshot.
Oh, thank you. So, so it's not a question of should they, shouldn't they. It's just a question of where can I get back on track the fastest, right? Okay. So, important thing to note, snapshots aren't just for clones. They can be for recovery, right? We offer those in Cloud Volumes, but more than likely, folks are going to be using them for cloning because that's the day-to-day life of what we hope people are doing, right? And again, these types of things are what start putting us ahead of the curve when we talk about the difference between Cloud Volumes and just leveraging the hyperscaler block storage. In an ideal scenario, the reality is a customer is going to be using both. They're going to choose the workloads that are going to need something as resilient, dynamic, et cetera, as Cloud Volumes. By the way, I haven't even talked about the resiliency aspect of this. All of the hyperscalers have different availability for their block storage. Some of them tie it to the availability of the virtual machine, which in that case is 3 or 4 nines. And then some of them tie it into an actual storage. Actually, there's only one who publishes AFRs, and that is Amazon. So kudos to them for being honest. They have a 1 in 500 or 2 in 1,000 annual failure rate for volumes that they publish, and they're okay publishing that, right? But what does that mean? That means that in the cloud with the cloud native block storage, you run the risk, and you have to choose whether that risk is going to be something that's going to impact your decision of actual data loss. All right? So, moving on. I'm going to demo some stuff. How much time do I have? Time check.
You have 26
Oh,
minutes.
this is rocking. Okay.
May I, I'm sorry, ask one quick question?
And he just took a minute away. 25. All right.
I'm sitting.
This better be good. Well, now that you commented on that, it's 24.
So
Absolutely, yes, sir.
I received a presentation on this stuff, and like I say, I think it's really cool. Has there been significant changes other than the name to HPE Cloud Volumes subsequent to its original Nimble product?
So its original release? Yes. There's been changes in feature set with what you can do as far as with replication. There's been changes with the hyperscaler availability. And by availability, I don't mean downtime. I mean, like, I can present now to Google, for example.
Okay.
There's also been enhancements with certifications and security, and we're constantly improving those. And then we are soon to have an enhancement coming out that is going to be pretty impressive, and I just encourage you to keep your eye out on Discover More Munich. So that's right around the corner.
I'd like to be there.
Yep. Or at least keep an eye out for the announcements of that. I think that'll be a really exciting thing to talk about.
All right.
All right.
Great.
So we have had several enhancements, mostly in the feature functionality, and also in the as a service. So in the UI, how I interface with the APIs. For example, when we originally launched, we just had REST APIs, and then we realized that most people use Python in the cloud. So now we have a Python toolkit. So little things like that. At every point in time, we make modifications based on what the cloud native use case is. We also have, of course, containerization integration. That's another enhancement.
Absolutely.
So we originally started just with Docker. Now we support also the Flex Volume driver. And we're soon to roll out with the CSI driver as well for Kubernetes support.
Thank you.
All right, so there have been quite a few enhancements. All right, good question. So what does it look like? Let's create a cloud volume. I'm going to start by going to the UI because it's simple to read. This is what it looks like when you log in. What I'm doing here is I'm creating a cloud volume. In this particular account, I have it tied to two hyperscalers, AWS and Azure. So first thing I do is I choose the region and then the VPC within that region, because remember, it's a dedicated connection to the VPC, a dedicated secure connection. Notice I can modify my size and IOPS independently of each other. And then I can choose my cloud application. This ties to block size, whether it be 8K, 16K, 4K, et cetera, right? I can choose my snapshot schedule, as well as whether or not I have encryption enabled or disabled. All of these options, by the way, are available in the API. So I can create a volume from the UI, or I can create a volume from the API. Here is what it looks like when I drill down into the volume itself. Now, up here I didn't have any info site data, and that's because I just created the volume. Naturally, I haven't done anything with it, right? But you can see here status about the tier that it's in, the performance, the network that it's provisioned to. Any virtual machine that is in this network, I would be able to map this volume to. We have automatic discovery of the VMs within that VPC, in the case of AWS, or VNet, right? I could have automatically connected it from the portal through an API call, but what I'm doing instead is I'm showing you that should you want to manually connect the volume, we also have a little commandlet that runs on the host itself, in which you can execute commands to go ahead and connect or map or create volumes, et cetera, right? So it's just a little commandlet that runs at CVCTL. Once the disk is connected, and I'm running this commandlet, by the way, from the actual virtual machine in the cloud, it's just SSDD, right? So at that point, this should look like any other type of addition of a disk or drive device to a machine. I'm showing it to you on Windows simply because it's easier to see, but of course, this could also work on Linux, right? Just like I told you, we can create volumes through the UI. We can create them through the API. Again, here I am leveraging that CVCTL, which is that plugin. What I did is I executed a one-line command to create this volume, and it created so fast that I had to switch over to the UI and actually refresh it, because that's how fast the API call works. Second command that I did here is just to essentially map or create the ACL from Cloud Volumes to the virtual machine, and then finish the handshake from the virtual machine. Once it's connected, again, I can go into disk management. I see the new volume, and at that point, I just bring it online. I format it, create a partition, et cetera, give it a drive letter. All right? And it's available at that point to the operating system. All right? Okay. Now, modifying Cloud Volumes again, even a newly created Cloud Volume, right? We can modify performance and capacity independently of each other. Let's review. Hyperscalers, their block storage, all of them are tied by capacity and performance in a scale. So they're tied in a ratio. Typically mostly linear if you look at it on a graph, right? So what I did there is I just showed you how easy it was to change capacity and IOPS. And you'll notice when I changed the capacity, it didn't do anything to my IOPS, right? They're completely independent. Provisioned IOPS SSDs at Amazon sorta, kinda, maybe a little bit work like this. They work in a range. So you can provision up to a certain amount of IOPS based on the capacity that you've provisioned. In order to get to that next tier of IOPS, you have to, of course, provision more capacity. The closest thing that's going to come to Cloud Volumes in the case of independently scaling capacity and performance is the Ultra SSD that's coming out. It's from Microsoft Azure. It's still in beta and private beta to boot.
It GA'd about 3 weeks ago.
It did? In all regions?
Yep.
Okay.
It is in US East, Amsterdam, and Singapore.
Okay, so it's still mostly private beta in the rest of the regions, right? So that Ultra SSD, however, has a per CPU, per hour cost. It has a IOPS cost, it has a throughput cost, and it has a capacity cost. So all of those bundled together per hour equate the cost of your device, meaning it's going to be expensive, right? And I still haven't tested it because it's not in a region that I can test it yet, but I'm really curious to see if it really is completely decoupled from capacity and IOPS provisioning, all right? So this is another visual demo of modifying capacity, of modifying performance independently of capacity, except I've done something a little visual here, and that's I've got an iometer workload running on the virtual machine. You'll notice the volume is set to 300 IOPS, and if you look at my iometer, it's around 300 IOPS. So 300 IOPS here, bring up iometer, 300 IOPS here. Everything's matching, life is good. So now what I'm going to do is I'm going to simulate, and by the way, this could be totally scripted. This could be wrapped into functions as a service in AWS. Maybe on that Sunday night, you need to increase the IOPS. Okay, this is dynamic, up and down how you need it. So what I did is I increased it to 1,000, and now look, we're at 1,000. No downtime to my application. If I change capacity, again, no downtime to my application. All of that is dynamic. All right?
I'm sorry, I don't know much about the credit system, but how granular is it? So if I need an extra 1,000 IOPS or an extra couple of, gigabytes or whatever, is that the kind of thing that I can pay for?
Yes, it is. So what you do, think of it like a Starbucks card. You put money or credits on it. And then at all points in the game, whatever you do in Cloud Volumes comes out of that Starbucks card. All of our pricing is available online. So if you go to the HPE website and you go under Cloud Volumes, we've got a nice little chart there that gives you all of our pricing for not just the tier of storage, but also what we charge for the IOPS. And what's also included as part of the purchase, because you do get a certain amount of IOPS free as well. Okay.
So what happens when you run out of credits? Does the volume go offline or?
No! We would be very bad people if we did that. No, we don't take the volume offline.
100% guarantee out the window. Finding ransomware.
You just have one IOPS.
Yeah. Actually, we've had quite a few people tell us that we are very forgiving, even more forgiving than the hyperscalers themselves. Chances are, if you don't pay your bill, you're going to have the compute go offline before we go offline. We work with our customers. Okay. We want them to have a good experience with us. And so to boot, we also acknowledge that some people are locked into capital life cycles or operating life cycles for budget, right? So we do give them some room and flexibility to true up, right? But it's just like a Starbucks card. You run out of credits, you put more on them, right?
When you present the volume to the VM, so some Windows and Azure here, because that's what I'm most familiar with, how does Azure see that volume? Is that an actual disk resource according to Azure, or is that a network resource that you're seeing over there?
That's according to Azure, it's a network resource at that point.
Okay.
It'd be something that you connected over the network. Actually, and that gets kind of tricky too, because people assume that block storage in the cloud is directly attached to the virtual machine. For those of you who need to know, it's not. It goes over the network.
Yeah, it's all. Yeah,
and then,
network. How do you connect the network into your, in this case, VNet? Is it would it show up as an express route? Or
So we connect, in the case of Azure, it's an express route. In the case of AWS, it's a direct connect, a dedicated, all of these are dedicated links, by the way. And then in the case of Google, it's an interconnect.
okay.
Okay? All right. Good questions. All right, so now I told you about this kind of gap, where we fit in, where we start coming ahead, and we start coming ahead real quick. So we created those volumes 2 demos ago, right? So now I'm going to add a little bit of a marker in one of the volumes that I created. And it's just a simple text file so that I can prove the point. And I'm going to type something in it because for some reason I can't just touch. You know how you do touch in Linux and just put a file out there? I can't do that. I have to put something in it. And in this case, I said hello or something like that. It doesn't matter. Because it's a new volume, there's no snapshots. So the first thing I'm going to do is I'm going to haul off and create a snapshot. I can take a snapshot through the API as well. So again, imagine a CI/CD pipeline type of scenario where you've created a change, you immediately need to take a snapshot to then move on to the next clone. You can do that too, all right? So now that I've created the snapshot, all I did is I went and I right-clicked on the snapshot and said create clone. And then I map it to the cloud of my choice. I choose whether I want to protect the snapshot because guess what? Sometimes the snapshots need to have snapshots, right? Sorry, the clones need to have snapshots. And then once the clone is available, it's just like any other cloud volume. I go and I connect it to the virtual machine. Now, because this is a lab environment, and I'm not allowed to spend a lot of money, I'm tying it right back to the virtual machine from whence it came. But this could have easily been a different virtual machine in the same hyperscaler. It could have been a different virtual machine in another cloud. And I'll actually show you that. I'll show you how I move a SQL database from one cloud to the other in the next demo. But anyway, here is my clone. If all goes well, that text file that I created previously should be there, and it should have that same wonderful hello text that I put in it. And sure enough, there's the file, and there's the hello. And at this point, I know I can't help myself. I had to say hello back. So demo complete, right? Now, one of the other things, and I talked about this briefly with DHCI, but now I showed you some cloud native kind of use cases. With the whiteboard, we started with the cloud native, but now I want to circle back to that data has gravity question and data mobility from on-premises to the cloud. So a couple use cases we can target here. Imagine where I'm in the data center and I want to replicate my data to the cloud for the purposes of DR or backup. Right? Again, we do that with built-in replication for nimble storage. We can fail back, by the way, with Delta, because just like I can set replication from my on-premises environment to cloud volumes, I can replicate from cloud volumes back to my on-premises environment. I can replicate back to the same array. I can replicate to a different array. All right? And should I need to, I can promote that data and connect it to cloud compute. In the case of test dev analytics, bursting, you name it, I'm more than likely going to, rather than promoting that data and making it the authoritative data set and then replicating back on-prem, more than likely what I'm going to do is I'm going to create a clone and again, connect it to the compute of my choice. But here again, key point, I'm starting with my original data set on premises. I moved it to the cloud in an integrated fashion, meaning I didn't need to have an external data mover. I didn't move it out of band. I made use of the existing replication technology that is built into HPE Nimble Storage. So how easy is it to configure this replication? Well, let's look at that. You can actually drive the configuration of replication from the Cloud Volumes portal itself. The only thing is that you have to access the Cloud Volumes portal from a network that has access to the array GUI, right? So you would do this through VPN or from on-premises. First thing I'm doing is I'm configuring a replication store. I need a bucket from which it's going to, for where this data is going to land. Now, because it's a lab environment and I don't have a lot of space, I only created a tebibyte replication store. The reality is this is going to be more like 30 tebibytes or something that's going to fit quite a few volumes from the on-premises array. Next thing I did is I went to the on-premises replication partners menu, and then I went to new on-premises replication partner. Here, I'm filling out the information. I've given it a common name or a simple name that I can refer to the relationship on. Here's the host name of my array, credentials to log in. I've chosen the replication store that I want to create as my replication relationship or my replication target. Think of that replication store very much as a destination or a DR array where I can just dump a whole bunch of volumes. And now if I go to my array, there it is, automatically configured. The API call was made on the back end. That's how quickly I can set up replication.
That's nimble.
Uh-huh. And at this point, for those of you familiar with replication, all I do is I go to my volume collection, which is my consistency set. And I click on a little drop down and I say replicate to, and I choose this name, replication, which is my replication store. On the next snapshot, it starts moving data to the cloud for me. Just like with on-premises replication, I can throttle this as well. All right? Once I've replicated my data to the cloud, I can promote or clone from that replicated data. In this particular case, what I'm showing you is a promotion because we've built some automation into it. So, oh crap, I need to move data set to the cloud, or maybe it's not oh crap, maybe it's a conscious decision. I want to move, I'm going cloud first, I'm moving this to the cloud. So the first thing I do is I stop replication, and at that point, I can go to my replica volume, the one I just replicated. I can see it's eligible for connection to the cloud or promotion. We call the connect to the cloud, we call promotion connect to the cloud and cloud volumes. And I choose my cloud account, my region, et cetera. This looks very much like the wizard you would follow for a cloud volume. I also tell cloud volumes the performance that I want for that particular volume. And once I confirm this, the volume at that point is a cloud volume available for me to attach to any of my compute, right? So if I go to the cloud volumes window, there it is right here, and I can now attach it to my virtual machine. So here I am in the virtual machine. I'm just going to execute that one command from the CLI to connect the volume. And once I do that, my data set is available for whatever application or use case I have in the cloud.
It's all driven by REST APIs also, right? It's all driven by REST.
CVCTL is essentially using an API on the back end to connect. Yes, sir.
How's the VM talking to the storage?
How's the VM talking to
The storage.
cloud volumes?
Yeah.
It's through the CVCTL, which is essentially making calls to the API.
So something proprietary? Just something like iSCSI?
No. For example, we have a REST API that you can make calls to yourself. The CVCTL is just a plugin that has automation built into it in the form of consumable commandlets. But let's say you don't want to use CVCTL and instead you're a PowerShell junkie. We have a PowerShell module that has wrappers to all of the APIs so you can execute the same workflow. It's going to take more commands, right? Because instead of having a program built by us, you now have to do each one of the API calls independently. But it's available. Should you want to do REST API invocation directly, you can. Should you want to use, for example, Python, we also have a Python module that has wrappers to all of the API calls.
Yeah, but how's that disk actually presented to the host?
iSCSI.
Yes.
It's essentially iSCSI.
Over iSCSI, okay.
Yes. It's all network-based. Okay?
But okay, never mind. That was
Yeah.
my question. Because think about routing and you know, all the business. It's not routed. It's because it's direct connect or via.
We are plugging it directly into the VPC. The only time you have to worry about routing is if you peer the VPCs or VNets and you want to connect to that disk, which you can do, then you're going to need something to do the translation or the route in between the peering. But that's normal to peering VPCs or VNets, right? So if you want to share compute, now we're getting into the clouds weeds here, but if you want to share compute between two VPCs or two VNets, et cetera, and you want to peer them in a certain way, then you're going to need something to translate or handle the communication across. Unless you don't want to peer, right? In the case of Google, you can span, VPCs are cross-regional resources, which means that you can have multiple regions within a single VPC.
Can this be presented to VMC on AWS, or is that
So we can present iSCSI volumes to VMC and AWS virtual machines. We cannot mount directly into the administrative VLAN of VMC right now.
Okay.
That is something that we have a very good partnership with VMware, and it's something that we're working for them with the future. All right?
I just think where the
Okay.
initiator will be and all that.
All right, so let me show you what it would look like to take a data set driven by an application to the cloud. So here what I have is a SQL database. This one is running on premises. It is backed by HPE Nimble Storage volumes, and they have already been protected by a volume collection, and that volume collection is set to replicate to a particular replication storing cloud volumes. These are my volumes, my replica volumes in cloud volumes that back that SQL Server database, and I can get the information here, not just by querying for the replication store, but for the source array as well. I have the same snapshots that are replicated, and I can clone from those snapshots and then present them to my compute. But I did tell you that We can do everything via scripting because of our APIs. And to your point, Mr. Cherry, what I've got here is a PowerShell script that I have built myself leveraging REST. Okay? Once I run this script, what I'm doing is I'm authenticating to the Cloud Volumes portal. We have a REST API reference that tells you how to do all of this, right? So I'm authenticating to the Cloud Volumes portal. I'm cloning from those replica volumes, right? And then I'm also handling the ACL mapping of the volumes to my VMs in the hyperscaler in the cloud. This particular case, I'm using RHEL in Azure. And for those of you who are familiar with the way connectivity works in RHEL, very much like in Windows, you have to create a mount point and online the volume. In RHEL, you also have to do the same thing here. So what I'm doing is I'm mounting, after I've created my mount points, I'm mounting my volumes to my RHEL instance. And at that point, they'll be available and online, and I can read the data in them. So if I go right now and I log into, since I'm on the command prompt, I decided to just kind of do this very quickly just to show that when I switch windows, I'm not jumping machines and pulling the wool over your eyes. I'm going to log into the SQL instance, and if I query it, we're able to see the version. It is SQL 2017 running on RHEL, and I only have system databases in this particular SQL Server. No user databases attached. I'm now going to switch to SQL Server Operations Studio, which gives you more of a GUI representation of what's going on the system. Again, I only have my system databases attached. All I do right now is I execute a T-SQL query to read the data files that are in those volumes and attach my SQL database. Right? So that's what this here, create database, give the database a name, on these file names for attach. Once I execute that, there is my database moved to Cloud Volumes. And that's how fast it was. This wasn't fast forwarded. Okay? Cool, huh?
Yeah, totally.
Something more than a text file. Now, I'm going to do the same, but I'm going to, instead of going from on-prem to the cloud, I'm going to go from one cloud to another, right? So here I am, back in SQL. Here's my database. I happen to be running this particular database in AWS, all right? If I go to HPE Cloud Volumes, this is the volume that happens to be backing that particular database, right? You can see the information about my VPC as well as the name. For those of you who are paying close attention, TME Staging SQL 1 is the name of the server, also the name of the instance. I'm going to go ahead, and the way I'm going to do this is through the GUI, just kind of a good show and tell. I'm going to choose a snapshot, and I'm going to clone it, and I'm going to go ahead and, since I've never connected to Microsoft Azure yet, right? This is how easy it is to create a circuit. I've entered the information about my VNet, resource group, etc., and automatically the circuit was provisioned and my volume was given an express route so that it's available to my virtual machine in Azure. All right, so we can do this on the fly. Next thing I did, you'll recognize this little cvctl command. All I'm doing here is I am connecting the volume. Since I've never run the command before, the other thing that it did is it went ahead and configured iSCSI for me, made sure I had the sessions, the appropriate number of sessions, made sure it checked for hot fixes, anything that needs to happen on that virtual machine for iSCSI to work optimally. If I look at the volume after I've onlined it, I could see my data files. All I'm doing now is I'm executing a T-SQL command or script to essentially mount the database for attach based on those data files. I refresh, woohoo, there's my cloned database from AWS to Azure. That fast, didn't fast forward this. I happen to do a clone here, but I could have also detached it from that circuit in AWS and just presented the authoritative data set in Azure. Sorry, yes, in Azure. I get the A's mixed up sometimes. Finishing up here. Hybrid and multi-cloud experience for containerized workloads. Some of you are already familiar with this slide because we talked about it in the DHCI presentation, right? So I told you then, and I think the comment was, we're going to have to explain what HPE Cloud Volumes block is for us to really understand this. Now you've seen what HPE Cloud Volumes is, so what we're layering on top of that is persistent data management, right, in the form of either a Flex Volume driver, right, or a Docker plugin, Docker driver, that we also have if you happen to be using Docker, for the management of persistent data sets for your containers. Why is that important? Well, as we're talking about this modernization of applications, I think when containers originally came out, right, or actually they've been around for a really long time, but when they really came out with Docker, where they became popular, there was this idea that they were always going to be ephemeral. These workloads that are just going to spin up and spin down. Poof, they're available. Poof, they're gone. We're back to square one. Poof, they're back. And then people were like, I like the poof. That part's awesome. But I want the poof for SQL. And by the way, when the second poof happens, I don't want my SQL data to go away. I want that to stay. Thus, we now had to start thinking about the management of data outside of the container. So maintaining that same flexibility and dynamic workload that the containerized environments brings to the table, but at the same time, what do I do with that data that has some gravity, right? Good news is HPE has been in this game now for 3 years. My counterpart, Mr. Michael Mattson, can talk your ear off about persistent data management for containerization. But we are experienced in this. We knew from the start that this was going to happen. People were going to want to use microservices architectures for more than just ephemeral workloads. So we've been managing data external to containers for a while. We can do that in Cloud Volumes, and we can do that on premises. We can also do that for 3PAR, Primera, and I believe SimpliVity as well, right? We have, yep. Actually, no, you should be able to do it with the VMware integrated, right? So external data management is everywhere across all our platforms. In the case of Nimble Storage DHCI, what that means is I can run containerized workloads on premises, right? But then because of that replication, that data plane that I have built into Nimble Storage, I can get my persistent data to the cloud, and then I can spawn that containerized workload in the cloud immediately on any of the platforms that are out there or the ones that I choose to build. So when we talk about all of this modernization, taking applications that are on premises in these old silos or monoliths and modernizing them, now we can modernize them in place with the same set of APIs, same container runtime experience that we would leverage in the cloud. And the good news is we don't lose that. We can take it to the cloud with us as well. Opens the door to multi-cloud DevOps and CI/CD pipelines. And again, we integrate with all of the major container orchestrators. I've got Kubernetes and Docker there. And when I talk about these, I'm talking about container orchestration. Some of you brought up other management planes for the cluster itself, like, for example, OpenShift, Red Hat OpenShift. We have a validated design for that. Tying this into building upon that containerization integration with our announcement of our validated designs for Google Anthos, right? What we're talking about here is taking this integration to the next level, right? So we've got Anthos, which is going to be running GKE on-prem for us. We are handling the data services, the APIs, and the mobility between on-prem and the cloud. We have that multi-cloud flexibility because just like we are able to support multiple clouds, so is Google Anthos, right? Google Anthos is meant to be able to manage your managed Kubernetes instances, whether in the cloud, so GKE in the case of Google, EKS in the case of AWS, AKS in the case of Azure. Just like we can support multi-cloud, so too can Anthos from a management perspective, although some of the external cloud management from a containerization perspective through Anthos is still in beta, right? But we can manage the containers through a consistent set of APIs and the unified management via the GCP console management. So we manage and provide the data services plane. They provide the container management interface. Together, happy partnership. This is one of the things that we announced at Google Cloud Next, and we further talked more about it at Discover, right? So it's a great partnership. And again, it's building on the experience that we already have with external data management for containers. The workloads that we had, or the solutions that we were targeting that we had at the beginning of this slide deck, you remember that one slide deck with the different challenges? This particular solution is able to address them all in a very agile Mode 2 environment. Okay? Moving on. So I talked a lot about cloud, HPE Cloud Volumes block. Next item in our portfolio right now, We talked about it a little bit. People have been asking about it, HPE Cloud Bank Storage, right? So with HPE Cloud Bank Storage, we can address this long-term archival in the cloud. Ties in a store once. And what we're essentially doing is we're taking data, moving it with Catalyst, but we're essentially leveraging the object storage in the cloud, which is extremely scalable and cost efficient, to provide that next tier, that next stop for our archived data. New to the cloud-based storage service is support of the cool tiers or the cold tiers of object storage in the cloud. So when we're talking about Amazon S3, we're talking about Amazon Glacier. We also interface and are able to tier to cool tier Azure Blob Storage. That's a tongue twister. Cool tier Azure Blob Storage, right? Okay. So long-term retention is the goal here. Low cost, it's extremely efficient data mover when it comes to compression deduplication. It's secure with encryption, right? But what we're talking about here is minimal cost to get your data into the cloud and store it in the cloud. And it's end-to-end protection, because just like you've got it in the cloud, you can also recall it back. And again, keep in mind, for those of you who are familiar with the Discover More events, take a look at the announcements for Discover More Munich. There's something else that we're launching that's going to be part and parcel to this backup story. So the goal here, we're presenting the vision for hybrid and multi-cloud data storage management for cloud data services. Again, a big component of this right now is HPE Cloud Volumes block. We've built upon it with Cloud Bank, right? This is also now part of our portfolio. We're going to continue to expand the portfolio, but the idea here is for us to be able to provide at all points, right, for the entire data lifecycle management enhancements, right? So efficient and secure bidirectional mobility, any workload at any cloud. Industry-leading full-stack analytics, because this all ties into InfoSight Predictive Analytics. Cost-effective retention, recovery, and reuse, right? We want this all to be cost-effective and as a service. And again, we want to be able to recover not just on premises, but to the cloud as well. When it comes to availability right now, US East and West, Ireland and London is where we've got Cloud Volumes, and we're continuing to expand. APAC, Tokyo is our next region, launching now as we speak. All right? So the goal for cloud data services, workload optimized platforms. That's the base infrastructure. We want to go to the next level. What we're doing is we are leveraging APIs and data management infrastructure, whether in the form of InfoSight or APIs we build ourselves and leverage ourselves, to provide the app owner, the VM admin, the cloud admin, DevOps administrator, the infrastructure admin. At each point, they get to see and leverage the APIs that allow them to manage the platforms. Sometimes they don't even realize that they're managing the platforms, but they're getting their work done. And that's our goal, right? Kind of goes back to that first slide that I had, which is everything is a service. Everything through the pane of glass that the end user requires in order to do their job efficiently. That's the goal, and that's what we're building with our cloud data services portfolio. All right, so here you are right now. We're in Google Cloud Platform. What I'm seeing here, this is Anthos in a nutshell. I'm managing multiple Google Kubernetes clusters, both on-premises and in the cloud. What you're seeing here is a workload that happens, this user one cluster Fred happens to be running on-premises. This is running on GKE on-prem on top of our DHCI environment. It's a two-tiered or a two-pod application. I've got a database and a web app as part of my application. If I look at the specification for my database pod, you'll notice it has a persistent volume claim. Notice as well how if I go from the Google Cloud Platform to the storage menu, I see the information about that persistent volume claim and the storage class as well as the volume. That volume happens to be sitting on HPE Nimble Storage. Again, it's external to the pod itself. It's already in a volume collection. It's already replicating to the cloud. So if you imagine that two-tiered picture, I've just described to you the on-premises environment. If I go to the service endpoint of this on-premises application, what I've got here is just a .NET Core application simulating a movie warehouse. The problem with my application right now is I can put bad data in it. I have no data governance. So what I want to do is I want to simulate a pipeline to immediately fix this. So I'm a good little developer. I've checked out a development branch, gone into my development branch, gone into this particular view or model, actually, and I've added some fields for data governance. At this point, I add my repository, I go ahead and commit it, and then I push. Push just means I take the changes that are working on-prem and I push it to my development branch that I've created or checked out in the cloud. The moment I do that, I kick out a Jenkins CI/CD pipeline, or I kick off a Jenkins CI/CD pipeline. I'm leveraging Google Cloud Build to build my image. And this is my development image. I'm also leveraging Google Cloud to store my artifacts. The CI/CD pipeline automatically builds the image, deploys my Kubernetes cluster, or if I have an existing Kubernetes cluster, goes ahead and deploys my pods into the Kubernetes cluster. This is all happening in the cloud. And because I have gone ahead and replicated my cloud volumes to my volume to cloud volumes, one of the things I was able to do is leverage the back end volume that has been replicated to cloud volumes as part of my database pod. So if I look at the storage, now I see 2 volume claims. One happens to be in the cloud. This one's the cloud one. This one is a clone of my replicated data set from on-premises. Here are the specifications for the storage class. Because it's a demo, I put everything in the storage class. More than likely, these things would be annotations in a PVC. So no, you do not have to create a storage class per volume. Now, if I go to the service endpoint of this application that is now running in the cloud, it's an exact copy, including the data. If I go to it in the cloud, if all things, now is my test, if all things went well, I should see some red, and I do. So the changes that I committed to my model are now in effect. Notice all of the entries that I had on premises are there. Why? Because I'm using the same data for my database, right? So now I'm going to go ahead and execute the last step in my pipeline, which is a cleanup. I want to clean up the Kubernetes cluster that I created in the cloud for this. I want to clean up the pods, don't want them out there. Want to delete the volume, the cloned volume that I have in Cloud Volumes, don't need it out there either. And I want to go ahead and rebuild my production images with this change, and I want to push them to production now. All of that is happening in this last step. This is the power of containerization and microservices. Once that's finished, I'm going to go to my on-prem application. Notice I'm back to just one copy of the database and front-end app. If I go to my storage, notice I'm back down to 1 PVC, or persistent volume, and it's only on my on-premises cluster. I'm going to refresh my client access point. All my data's there. Life is good. But now, because I've done my job, guess what I see? A bunch of red. That fast. Created changes to an application, tested them, deployed them. Leveraging the data that I had on premises in the cloud to build it.
TDD.
All right?